When I use a word, Humpty Dumpty said in a rather scornful tone, it means just what I choose it to mean, neither more nor less. The question is, said Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, which is to be master? That's all. I love a good cold open. Hello, I'm Al Swigert. I'm mostly known as the author of Automate the Boring Stuff with Python, and this is the amazing Mutable Immutable Tuple and Other Philosophic Digressions. I originally gave this talk at PyCascades 2019, but I'm re-recording this for the web. I make a lot of references and recommendations for books and talks. There's no need to take notes. You can download these slides from bit.ly/amazingtuple. This talk grew from a basic question I had. Are tuples mutable or immutable? And the answer is, tuples are immutable. Everybody knows that. Thank you for coming to my talk. Enjoy the rest of your day. Okay, wait, there's more. Let's start this like a philosophical discussion and define our terms. What's a tuple? I'm pronouncing that word both ways so that everyone can tell me I'm saying it wrong. Well, a tuple are like immutable lists. They're in ordered sequence of data. Unlike lists, you type them with parentheses instead of square brackets. But if you only have one item in the tuple, the trailing comma is required. It's really the commas that make a tuple, not the parentheses. Now, for anyone who has read Luciano Romalo's fantastic book, Fluent Python, you'll know that tuples can serve as more than just immutable lists. But in this discussion, suffice it to say that tuples are immutable lists. Next question, what is mutability? So mutable means that it can change its value, while immutable means that it can't change its value. So while you can create a list and then change the items in the list, you can't change the items in a tuple. If you try, you'll get an error message. So tuples are immutable. Kind of. I mean, can't we just reassign this variable to a different tuple and thus change the tuple? Well, no. Technically, this isn't changing the tuple so much as creating a new tuple and replacing the old tuple in the variable. But that answer leads to more questions. What's the difference? And why do you even need tuples if we already have lists? And are tuples immutable or not? Before we go down this rabbit hole, I want to point out a common Python gotcha. Let's say we create a list and store it in a variable named spam. Then we copy spam to a variable named eggs, and we change the first item in spam to the string change. What are the contents of the eggs variable? You might know this gotcha already. The eggs list has also been changed, just like the spam list. And this is because spam and eggs are actually the same list. To understand why this happens, I'm going to use the visualization tool at pythontutor.com. If you've never used pythontutor.com, check it out. It's great at showing you what is going on in your code. Here's our 3-line program. At the top is when we execute the first line, and it creates a list for the spam variable. You can see the spam variable in blue pointing to the list object in yellow. The middle is the second line executing, which copies the list to the eggs variable. Notice that we still only have one list object. It's just that both spam and eggs refer to it. And that's why at the bottom, when spam is changed, it's changing eggs as well. Now, I used to use a box metaphor for variables, like the variable is a box and the list object is stored inside the box. This doesn't work out too well for Python. It's better to think of variables as name tags or labels that you attach to the object. These labels point to the objects. The object isn't inside the variable. Now, in this new example, I have changed the list to a tuple. You still have two variables referring to the same tuple object, but the tuple is immutable, and you'll get an error message if you try to change it. So immutable objects like tuples don't suffer from this same gotcha that mutable list objects do. What about the other data types, like integers or strings? Well, integers and strings are also immutable. You can assign the integer 42 to spam like we do at the top, and then assign spam to eggs like we do in the middle. Both variables refer to the same integer object. And if you try to change spam, like at the bottom, you're actually creating a brand new string object and attaching the spam label to it. You're not going to run into the gotcha that we have with lists because integers and strings are immutable objects. Now, in Python, everything is an object. Lists and tuples and dictionaries are objects, but so are integers, floats, and strings. Functions, classes, and modules, all of these are objects. It's not like Java where there are primitive data types and object data types. Everything in Python is an object. Now, when we assign spam to eggs, we aren't copying objects. In fact, assignment never copies objects in Python. It only copies the label. Ned Batchelder has a great talk on this topic called Facts and Myths about Python Names and Values. I draw on some of the things that he covers in this talk, but it's worth it to see Ned's talk as well. But keep this in mind, everything in Python is an object. Another term we need to define, so what are objects? I'll get back to this in a moment when I cover the Python object model, but first let's look at one more code example. What happens when we have a tuple that contains a list? The tuple is immutable, but the list is mutable. And when we change the mutable list, we also change the immutable tuple? So how is that possible? Well, let's take a look at pythontutor.com again. Remember, variables are labels, not boxes. And lists and tuples aren't boxes that contain objects either. They contain labels that refer to objects. So pythontutor.com is slightly inaccurate here because this slide should really look like this. The tuple and list don't contain integers and strings. They contain labels that refer to integers and strings. And this view makes it clear at the bottom that the list changes what objects it refers to, but the tuple doesn't. So the tuple is still immutable. But at the same time, it's clearly, obviously changing its value. So does this mean tuples are mutable? What do we mean by these words? Mutable, immutable, object, value. It's easy to use these words interchangeably or inconsistently, but let's think about what we mean when we say them. Now, you can go a long time without knowing the exact definitions. I was programming in Python for well over a decade before I found the data model page in the official Python documentation. The Python data model, also sometimes called the Python object model, describes the lower-level details of what Python objects are. Remember, everything in Python is an object. The Python data model tells us that every object has three things: an identity, a type, and a value. Yay, more words we need to define. Okay, an object's identity is a unique integer that never changes during the lifetime of the object. From the moment the object is created until it's recycled by the memory manager's garbage collector, it is the same and is unique. In CPython, the Python interpreter you download from python.org, the identity is the object's memory address, which is pretty convenient. This is an integer that's unique and won't change. You can find the identity of an object with the built-in ID function. You pass it an object, or a variable that refers to an object, and it returns the integer identity of the object. Now, you can use this to determine if two variables refer to the same object by checking if their identities are equal. Here we can tell that eggs and spam refer to the same list because the object they each refer to has the same identity. In fact, this is what the is operator does. It's a shortcut for checking identity equality between two variables. Now, every object has an identity, and every object has a type. In Python, the terms type, data type, and class all mean the same thing. Like identity, an object's type never changes during the object's lifetime. Type is something like integer or string or tuple. You can find the type of an object with the built-in type function. So you pass it an object and it returns the object's type. Remember, everything in Python is an object. And that means that what the type function returns is an object also, and that object has a type. It's the type. Okay, so like the identity, the type of an object never changes. So if you're converting a string to an int, you aren't actually changing the string object's type. What's happening is that a new int object is created, and our variable now refers to that new int object. And we can see this for ourselves by checking the identity of the variable's object. The ID function gives us different identity numbers. So every object in Python has an identity, a type, and the third thing is a value. This is the most familiar property. The value is one of a range of values determined by the type. So there's effectively an infinite number of possible integer and string values, but the Boolean type only has two possible values, true and false. And the none value is the only value in the none type. So, is there a built-in function to tell us the value of an object? Well, we think of value as this well-defined thing, but when I looked closer, value is kind of nebulous. So I'm going to ask a question that sounds like it's straight out of philosophy. What is value? If you want to see an object's identity, you can call the ID function. If you want to see an object's type, you can call the type function. But if you want to see the value of an object, there are actually two built-in functions, stir and repr. The stir function, or string function, returns a human-readable string form of the object's value. This is straightforward for objects like integers and strings, so let's use a more abstract example with a datetime.date object. Here I've called datetime.date to create a date object that represents January 20th, 2020, and I assign the birthday variable to refer to this object. Now when I call string, it returns a string of a human-readable form of the object's value. So what string or stir returns is defined by the datetime.date type. But this string of the object's value is not the same as the object's value. If we try to use the equality operator on them, it evaluates to false. Stir doesn't return the object's value, but rather it returns a string that represents the object's value. It's a subtle difference. Now the other built-in function for seeing an object's value is repr. The repr function produces a string that, ideally, is a representation of Python code that would recreate the object. Passing the date object to repr gives you a string of the code that creates the date object. The reason we have two different functions is because the stir string is useful for displaying object values to humans, and the repr string is useful for more technical contexts like log files or debugging messages. It isn't always possible to make a repr string of the Python code to recreate the object. For example, I've created a foo class, and the default implementations of stir and repr are fairly useless. You can tell from the angle brackets that this string would not be valid Python syntax. You couldn't recreate the object using the repr string. Now the stir and repr functions return strings that can describe an object's value, but that's not going to be the same thing as the actual value itself. Even if we type the variable that refers to the object into the interactive shell, that's just going to show us whatever the repr function returns. That's not the object's value itself. So we need to know the value so that we can tell if an object's value changes, so that we can find out if the object is mutable or immutable, and then we can find out if tuples are mutable or immutable. And this is getting complicated, because mutability isn't a property of Python objects the way identity, type, and value are properties of Python objects. Now let's look at the Python data model documentation again. It tells us that if an object's value can change, it's mutable, and if it can't, then it's immutable. But it doesn't tell us an exact definition of value. I did eventually find it. It's in a completely different section of the Python documentation, section 6.10.1. It has this line, "The value of an object is a rather abstract notion in Python." Yeah, no kidding. But it says the value of an object is dictated by the equality operator. And I can agree with that. Even if this wasn't backed by anything in the official Python documentation, I think I could make a pretty good case for this. For example, the integer 42 and the floating point number 42.0 have the same value. The equality operator says they are equal. Now, I can't tell you the true nature of the value 42. I'm sure it has something to do with life, the universe, and whatever. But however you want to define value, I can tell you that these objects, 42 and 42.0, have the same value in Python. Meanwhile, the integer 42 and the string 42 have different values. The equality operator says their values are different. But if you want to know something kind of weird, the Boolean true and false values are the same as the integer 1 and 0 values. Now, the story behind that is Python originally didn't have a Boolean data type. It was added later, and when they added it, It was just easy to make booleans a subclass of integers. So you can use boolean values anywhere you can use the integers 0 and 1. You can mathematically add true plus false plus true, and you get the integer 3. You can use true as an index of a string and get a substring. And now you can write code like this, but please don't. It's completely unreadable. But if you really want to bake your noodle, check out Python 2. Capital T true and capital F false were only made keywords in Python 3. In Python 2, you can use these names as variable names, which means you can assign false to true, and then true is false is true. So please switch to Python 3 if you haven't yet, otherwise you might destroy the space-time continuum or something. So if mutability is based on value, and value is based on the equality operator, what is the equality operator based on? And that's easy to answer. The dunder equal dunder special method. Python classes, which is to say Python data types, have special methods that begin and end with double underscores. We call them double under methods or dunder methods. The dunder equal dunder method overloads the equality operator. So say I have a cat class, and I define a cat as being composed of a color and a weight. Now in reality, cats are much more than just color and weight. Don't confuse the map with the territory. This is just how I'm defining cats here in this program. I'm overloading the equality operator so that another object has an equal value to this cat object's value if its type is cat or a subclass of cat, and it has matching color and weight. So I can create two cat objects and assign the variables Zophie and Puka to them. When I compare them with the equality operator, Python calls dunder equal dunder, and it returns true. So these two objects have the same value because the equality operator says they do. Though I can change this as much as I want. Well, let's change dunder equal dunder so that two cats have the same value if they have the same color, and weight doesn't factor into it at all. Then I can create two cat objects, Zophie and Jasper, and these cats are both gray but have different weights, but Python considers them to have the same value because the value of the weight attribute isn't part of the value of the cat object. Now this seems quote-unquote wrong because it seems like these two cat objects should be different, but maybe this definition in the dunder equal dunder method fits the requirements for this particular cat class. Now we can take it even further. If I always return not other is self, then a cat object has the same value as literally everything except itself. And so Zophie is not equal to Zophie, but Zophie is equal to the string cheese sandwich. Now this seems very wrong, but this is Python programming. There is no right or wrong, only dunder methods. Now I can't think of a case where code like this is necessary or even useful, and it also breaks dictionary hashing, but if the use case demands it, then this is the quote-unquote right definition of value for this class. So there doesn't seem to be a consensus on what value is in the Python language. You could argue that the integer 42 should have the same value as the string 42, but the equality operator, that is the class's own dunder equal dunder method, says they don't have the same value. And I think what a type says about its own definition of value is the closest thing that we're going to get to a referee on this. I will now tell you if tuples are mutable or immutable. We have two tuples, spam and eggs. They have different identities, so they are different separate objects. The equality operator says that they have the same value. So no matter what you say about the nature of their values or value itself, we know that they are the same value according to the equality operator. Now we run this code, and we change the list inside the spam tuple. And when we compare their values again, they do not have the same value. Therefore, one of these tuples must have changed their value. Therefore, tuples are mutable. Now this is the part where someone says, yeah, Al, but tuples are immutable. Everybody knows that. And that someone will also say, the Python data model documentation says that the tuple is still considered immutable because the collection of objects it contains cannot be changed. Yeah, I can't argue with that. I even showed that in my earlier example. The Python data model documentation continues, so immutability is not strictly the same as having an unchangeable value. It is more subtle. It is more subtle. I spent weeks on this presentation trying to show that tuples are mutable, and it gets refuted by 4 hand-waving words in the documentation. Blah! The question is, said Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, which is to be master, that's all. We can argue about what mutability means in Python because, ultimately, humans define words, and not the other way around. Maybe we're thinking about mutability wrong. Maybe I'm thinking about mutability wrong. Maybe the Python documentation is wrong. Maybe data types, like tuples, aren't mutable or immutable, but individual objects are mutable or immutable. I mean, that could be a whole other talk, but I'm running out of time. So I'll leave you with one more philosophical question. How many colors are in a rainbow? 7, right? But this isn't a rainbow. This is. So how many colors does it have? 1,000,000? Infinite? It really depends on how you define color. But a small-minded person might say, no, 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 rainbows have 7 colors. They can only have 7 colors. We all learned this in kindergarten. The colors of a rainbow are Roy G. Biv: red, orange, yellow, green, blue, purple, and a different kind of purple. Maybe these 2 words, mutable and immutable, aren't as concrete as we first thought. It's more subtle than that. Maybe having just 2 words isn't enough to fully describe Python objects, or if we do use these 2 words in a casual, colloquial sense, that isn't the final sense. Well, I'm a programmer and not a philosopher, and I've been talking for 25 minutes, so maybe it's time for me to listen to what others say about what identity, type, and value means to them. Thank you very much.